class. Today we're going to be talking about section 6.6, rational exponents. So the definition of the first exponent, b raised to the 1 over, can't tell if that's an m or an n, I'm going to say n, power, for any real numbers b and any positive integer n, b raised to the 1 over n power equals the nth root of b, except when b is less than 0 or negative and n is even. The definition of b to the m over n power for any non-zero real number b and any integers m and n with n greater than 1. What you do with the b raised to the n power is you take the nth root, so you take your denominator, put it over here, take the nth root of b raised to the n power, or you can put it in parentheses and take the nth root of b raised to the m. So for example, on the first one, write in radical form 28 raised to the 1/2 power. We're going to notice that 28 is greater than 0, so we can take the 1/2 power is the square root. So what they've done here is they've broken down the 28 into prime factors. So we have 2 and 14, 2 and 7. So you see you have 2 squared, and remember, any pair you can circle and pull out front. So this would be 2 on the square root of 7. The second example that we're evaluating -8 over -125, all raised to the 1/3 power. Notice that -8 is less than 0 and -125 is less than 0. But 3 is odd, so we can take this root. This is the cubed root, or the third root. I should say the third root. So you break it apart. You take the third root of -8, which gives you -2, and you take the third root of -125, which gives you -5. Then you want to simplify. Since we have a negative over a negative, it would be a positive 2/5. So let's try a few together. We are going to, on these examples, just write each expression in radical form or write each radical in exponential form. So this is exponential form. To write it in radical form, notice this is a 1, so we just take the 7th root of 11. We're not doing any kind of simplifying other than rewriting these. On the second one, we've got 15 raised to the 1/3 power, so we're going to take the third root of 15. On the third one, we have n raised to the 5/6 power. Remember that the denominator is the root, so we can take the 6th root of n, and I like to do mine in parentheses, raised to the 5th power. Now we're going to go backwards, and we're going to take the rational root and write them in exponential form, or the radical root and write in exponential form. So they're taking the square root of 47. This would be 47 raised to the 1/3 power, or 1/2 power, excuse me. Square root is to the 1/2 power. I was jumping ahead. On the second one, group what's underneath the radical in parentheses. We have 3a to the 5th b squared, raise the whole thing to the 1/3 power. On number 6, we're going to treat it like number 5, in that we're going to take what's underneath the radical, we're going to group it in parentheses. So we have 162 p to the 5th, all raised to the 1/4 power. Okay, so on the next screen, we'll actually try to simplify some. And these you'll be using the calculator is just fine to do these. Okay, so we're going to start with, we've got negative 27 raised to the 2/3 power. So we're going to take the cubed root, or the third root, of negative 27, and we're going to square it. So the cubed root of negative 27 is negative 3. We're going to square that, and that is going to give us 9. On the second one, we're going to take the third root, or the third root of 216. So you can put in your calculator the third root of 216, which equals 6. And on the last one, we're going to take the square root, since it's raised to the 1/2 power, the square root of 0.0004, and that is going to give us 0.02. That's it for this lesson. If you are at home and you don't have one of the calculators that I'm using, the Casio's, and you want to check one out for me, please email me and make arrangements so that you can come up to the office to pick it up. That will make these a lot easier if you have one of the Casio calculators. The TI calculators may do it. I'm not certain because I'm not as familiar with those, but the Casio calculators will do any root. I've hoped that this lesson seems pretty easy, and I hope you have a great day. I'll see you next time.